If you have this scientific notation and you need to make a process of addition or subtraction, I know you said that like this, it's easy for you in math, but I want to revise it with you. You have like this scientific notation plus this scientific notation. You know, we took the numbers repeated as common. In math, you are talking about that. Okay? Here, what's the numbers repeated? Huh? This exponent, 10 power of something, 10 power 3. Take it as common and make addition between this number and this number. Look, 5.4 plus 0.8 or 0.80 times 10 power 3. Finish this first, you will find it 6.2 times 10 power 3 as it is. If you want to addition. If you want to make subtraction, the same process. Let's move to another thing. We have something called accuracy, precision, and error. What's the difference among them? Let's see. First, what meant by accuracy and precision? In chemistry, you are dealing with numbers, and each number has its own meaning. So you have to be accurate in your numbers. Accuracy means if you have a measure, how close this measure or measurement to the actual or true value. How close to the actual or true value. But precision is a measure of how close this measurement to one another. How come? It means if you have boiling point of water, it's measured by scientists and it's 100 degrees Celsius. This is the boiling point of water, 100 degrees Celsius, boiling point of water. If you are making an experiment in the lab and you are making measurement for, or you want to measure the boiling point of water in the lab by thermometer, for example, something simple, okay? And you put this boiled water and thermometer, and the thermometer is, for example, 92.9. Then you repeat it again, the experiment, and you find it 99.8. Then you repeated it and you find it 99.99, and so on. Here 90, for example. Here 90, okay? All of them are very close to each other, yes, and also very close to the true number. If the value is close to the true number, the actual number, it means it's a accuracy measurement. If it's close to each other, it means it has precision, this measurement. Type. What if you measure the boiling point of water and you found it 97, for example, degrees Celsius? Then you repeat it again and you find it 97.1. You repeat it again, you find it 97.3. Then 96.9. All of them are close to each other, yes, but they are not close to the true value. It means these values have precision. They are close to one another, yes, but not accuracy. Why? Because they are not close to the true value. But what if you measure the boiling point of water and you found it 99.98, okay, and you repeat it again and you found it 97.1. At this moment, the readings called what, or they have what? The first one is very close to the true or actual value. It means the first one has accuracy, yes, but both of them are not precision. Why? Because they are not close to each other. Not close, 99 and 97. So they are poor precision. They have poor precision. But first one has good accuracy. You understand? I think you understand. It's easy, and you'll understand more if you see that. To evaluate the accuracy of the measurement, you have to compare this value to the correct value. At this moment, it has accuracy, or you can say accuracy or good accuracy. But to evaluate the precision measurement, you have to compare this value to one another if it's repeated or not. Look at this diagram and you will see the meaning here in this diagram. Look, if you point to this point and all of the arrows are in the same point, which is the correct or true point, we can say, because all of them are at the correct point, so they have good accuracy. They are very close to the true value. Also, they are close to each other, so they have good precision. But what if they are close to each other? Yes, they have good precision, but not close to the true value. So we can say poor accuracy. Good precision, but poor accuracy. But what if they are farther from each other? That means poor precision and also far from the true value. So at this moment, poor accuracy as well. You got that? So we got the meaning of accuracy and precision. Now we need to determine the error. What is the error? If you are measuring the boiling point of water, as I said, by thermometer, and the thermometer reads 99.1 degrees Celsius, not 100, you accept this value. Must be 100 degrees Celsius. This is the actual degree, but we have the reading 99.1. From these two readings, the actual one you know, and the measured one, you measured it by thermometer, you can find something called the error. How? You have something called accepted value, which is the correct value, which is and you have something called experimental value that you measured in the experiment. If you want to measure the error, just make the subtraction between experimental value and the accepted one. Let's try this example here. Look, we have the true value, which is 100, and we have 99.1, which is measured one. 99.1 minus 100, it gives you negative 0.9 degrees Celsius, because we make subtraction between the experimental one and the accepted one. The experimental one, which is happened in the experiment, 99.1. The accepted one, which is accepted by scientists, measured by scientists, which is 100 degrees Celsius. Make subtraction between them, you will find it's negative 0.9. If you want to measure the percent error, just put the error here, okay, but the absolute value of the error, without negative, I mean, okay, divided by the accepted one, okay, not the experimental one, the accepted one, measured by scientists, times 100%, you will find the percent of the error if you need the error in the form of percentage. Let's see this. You have boiling point 100, but you measured by 99.1. We need to calculate the percent error at this moment. How? Look. This is the rule, the absolute value of the error divided by the accepted value times 100%. Look, 99.1 minus 100, which is negative 0.9, but without negative because we need the absolute value, so it's 0.1, divided by the accepted value, which is 100%. It gives 0.9 percent. This is the percent of the error in this problem.